I hope I am audible to everybody. Please confirm. Anyone? Let's wait for 5 minutes more so that more participants can join. Then we will start. Am I audible, somebody?
Yes, sir.
Thank you. So we are waiting for 5 minutes. Then we will start. So let us start with some questions. So welcome you all to the tutorial 4 of multivariable calculus. Myself Guru Bachan from Department of Mathematics, IIT Jodhpur. I am a PhD scholar working in the broad area of fractal geometry and dynamical systems. I am the tutorial assistant of this course. Today, we will learn some illustration which are based on the lecture 4, which includes Lagrange multipliers, Taylor's theorem, error approximation, and multiple integrals and polar curves. So let us start with the question number 1. Find the equivalent Cartesian equation of the polar equation r is equal to 3 by sine theta minus 5 cos. So we need to find out its Cartesian equation, and we have given the polar equation. So try it first, then we will discuss here. Anybody have any idea that how you have to approach this question?
We have to substitute x equal to r cos theta, y equal to r sin theta.
Absolutely, absolutely right. So let me recall. that how we can convert Cartesian to polar equation and polar to Cartesian equation. So polar to Cartesian and Cartesian to polar. So we know that x is equal to r cos theta and y is equal to r sin theta. So either we can substitute this x and y value in Cartesian equation and then we will get our required polar equation. And the other way around is we know that r square is nothing but x square plus y square and theta is nothing but tan inverse y by x. So with this in polar equation we can get the Cartesian equation. Okay, so here we don't need to substitute like this. We just need to make some rearrangements in the given equation, which is like that. We have given 3 divided by sine theta minus 5 cos theta. So we can how we can rearrange it? We know that x is equal to r cos theta and y is equal to r sine theta. So we can multiply this sine theta and minus 5 cos theta to the left hand side and we get the following. So it will give us r sine theta minus 5r cos theta is equal to 3. So the next we know that what is r sine theta? R sine theta is y. So it will give us y. And what is r cos theta? It is x. So we can get y minus 5x equal to 3. I hope everybody understand this. If anybody has any doubt, you can ask. So if I would change this question in the way, suppose I am giving you r is equal to some 3 sine theta divided by sine square theta minus 5 cos square theta. Then what would be its Cartesian equation? Please tell me.
Sin theta y by r,
Sine theta.
y by r for the numerator.
Can you repeat it? Sine theta.
Replace sin theta by y by r in the numerator.
Okay.
Then cross multiply that r.
Okay.
So that will become r squared on the left hand side.
Hmm.
So cross multiply and use r sin theta y, r cos theta x.
Okay. Understood. Fine. So anybody else? So let me start. So first what we will do, we will again take this denominator to the right hand side and we will get the following. 3 sine theta. Now here is a square of sine, square of cos, and here is one sine. But here the power of the r is 1, while here is also 1. So what we can do, we can multiply the whole equation with one r. So it will give us r square sine square theta minus 5r square cos square theta equal to 3 sine theta. What I have done, multiply r on both sides of equation. So we can rewrite it as r sine theta whole square minus r cos theta whole square and 3 r sine theta. So we know that r sine theta is nothing but y and r cos theta is nothing but x, which can reduce to this. Okay. So can anybody justify what this equation represent?
Hyperbola.
Hyperbola. Nice. So how can justify it? 3y minus 5x square which will be equal to 0. So you can it complete square. So how will it will become? It will give you 3 by 2 whole square equal to 9 by 4. So this will be some hyperbola. Now let us move to the next question. Question number 2, which states that find the value of the double integral 0 to 1, 1 to 2, x minus y divided by x square dx dy. First try it yourself, then you will do it. Besides, further you can also further compute 1 to 2, 0 to 1, x minus y divided by x square dy dx. Compare both the results. So try. Anybody get some answer?
Split it to two terms, x by x squared minus y by x squared.
So ln 2 minus 1 by 4.
Ln 2 minus. Yeah, correct answer.
Okay.
So x minus y divided by x square dx dy. So first of all, we will split into two terms. It will be dx dy. Now, since here is first dx, so we will integrate with respect to x first, keep assuming y as constant. So we will integrate first this part and then we will integrate with respect to y. So it will give us ln mod x minus y by minus x 1 to 2 dy by x to the power n dx is nothing but n plus 1 plus c, where n cannot be equal to minus 1. Okay, so it will give us ln2 minus, or it will come out to be minus minus plus y by 2 minus ln1 plus y dy. So ln1 is 0, so this will be simply ln2 minus y by 2. I have simplified somewhat. Now we have to integrate with respect to y. ln2 is constant, so it will stay like this, y and y square by 2, again with the same reasoning. So it will give ln2, here it would be, since it is y square by 2 and 2 is already there, so then y square by 4 minus 1 by 4 minus 0 minus 0, so it will give you ln2 minus 1 by 4. So this is the first value of the double integral. Now I have asked, and I have changed the order of the integration, and I have asked you that what would be the value of this integral if I change this order of dx and dy. So anybody has computed this?
So same answer.
Why?
Same answer.
Yeah, I understand your answer is also correct, but can you justify that why the same answer is coming?
No, sir.
Have you watched the lecture?
No, sir. I have actually this week I was a little bit busy in my college, so
Oh,
I was not able to watch all the videos.
so let me confirm first. So this is 1 to 2, 0 to 1, x minus y divided by x squared. I think this was the integral, and if you will compute, let me compute once again. 1 to 2, it will give you, since we are treating x as constant, so it will give you xy minus y squared by 2, 0 to 1 dx. So it will give you 1 to 2, 1 by x squared, x minus 1 by 2 minus dx, 1 to 2, 1 by x squared, which is x minus 1 by 2 dx, which will give you 1 by x minus 1 by 2x squared dx. That means ln mod x plus 1 by 2x. This will be 1 to 2. This will give ln 2 plus 1 by 4 minus ln 1 plus 1 by 2. So this will give you nothing but ln 2 minus 1 by 4. So it is the same answer. It is nothing but the integral of 0 to 1, 1 to 2, x minus y divided by x squared dx and dy. And the answer is same because of the reasoning of Fubini theorem, first form. Let me state that Fubini theorem, first form. Let me first state it, then I will explain what this theorem says. So we will precise somewhat. So this theorem says, let fxy is a continuous function throughout the rectangular region R, which is defined as some a less than equal to x less than equal to b and c less than equal to y less than equal to d. Then it will give you that, it will guarantee you that if you will integrate this factor, then it will be nothing but a to b, c to d, fxy, dy dx, which is same as c to d, a to b, fxy, dx, dy. So it is saying if your function is continuous over the rectangle, that rectangle means you can say this is the region of the rectangle. So this is nothing but, I will draw it, x, y, this is some a, this is some b. I'm assuming a and b are positive. This is some c, this is some d. So over this rectangle, if f is continuous, and these, observe here, this a, b, c, d, these are constant, then we can say that we can switch the order of the integration and it will not affect our conclusion. Okay, so you can earlier also observe that since we have the limit as constant and our function is continuous over this region, then we can directly say without computing that the answer of this integral, double integral, will be the same as the answer of this double integral. Okay, clear now, Samadhi?
Yes, sir.
Okay, so let me move to the next question. Third one, find the extrema of the function fxy equal to x square y on the ellipse x square equal to 6. Find the extrema of this function on the ellipse x square plus 2y square equal to 6. So if I would write it in a smarter way, so that means we have to maximize or minimize the function, and subject to constraint is x square plus 2y square minus 6 is equal to 0. So this is our subject to constraint, and we have given this function fxy. So this is the question based on, you can say, the first lecture, I guess, Lagrange's multiplier. So try it. So what we will assume here, we have given fxy and we will take gxy to be x square plus 2y square minus 6. What Lagrange's multiplier says? Anybody? How we can apply Lagrange's multiplier?
Del F equal to lambda into del G.
Yes, absolutely right. So by Lagrange multipliers, we know that del f is equal to del g. So what is the gradient of f? It is nothing but I cap del by del y j cap of the function f, which is equal to
I del f by del x.
what? Yeah, I am writing that I cap del f by del y j cap. So what is the f? X square y. So del by del x of x square y I cap and del by del y of x square y j cap. So this will give you 2xy I cap plus x square j cap. Now you have to compute del g in the similar way. So it is x square plus 2y square minus 6. So del by del x of x square plus 2y square minus 6 I cap del by del y of x square plus 2y square minus 6 j cap. So this will give you 2x I cap. We will differentiate with respect to x and keeping other variable, independent variable as constant, 4y j cap. Now by Lagrange multiplier, you need to equate this 2xy I cap plus x square j cap is equal to lambda times 2x I cap plus 4y j cap. So this will give you 2xy I cap x square j cap will be equal to 2x lambda I cap and 4 lambda y j cap. So this will be 2xy equal to 2x lambda x square equal to 4 lambda y. So you get these two values. Now what we can do? We have given a subjective constraint, that is x square plus 2y square is equal to 6. So we need to find out this value of x square and y square in terms of lambda, and we can put in this equation to get some value of lambda, and then consequently the value of x and y in that way. So, and suggest me some good substitution technique so that I can substitute something. Anybody? How can we proceed now? We need to put the value of x and y in terms of lambda. So how can we proceed? Samedi, anyone? Can I write it like this? And what this will do? This will give you two possibility, either x equal to 0 or y equal to lambda. Right? Now suppose case 1 you are considering y equal to lambda. Then this x square equal to 4 lambda y will give you 4 lambda square. So x equal to, in fact, you don't need to calculate the value of x here because here you need to put only x. So this will give you, put this value in subject to constraint. So this will give you nothing but 4 lambda square plus 2 lambda square equal to 6, which is nothing but lambda square equal to 1, which will give you lambda equal to plus minus 1. So if lambda equal to plus minus 1, then y will be plus minus 1, and x square will be nothing but 4. Okay, then x will be nothing but plus minus 2. Okay, so what are the pairs you will get here? 1 2, 1 minus 2, minus 1 2, and minus 1 minus 2. These pair of points we can get where we need to check the value of this fxy, whether it is a maximum or it is a minimum. Now what if we will follow up the case of x equal to 0? So if we will follow the case 2 where if x equal to 0, here we have followed if y equal to lambda, then this x square 4 lambda y yields 0 equal
Points
to,
are wrong. Points are here x plus or minus 2 and y plus or minus.
can you speak a little louder?
X values are plus or minus 2 and y values are plus or minus 1. So points are 2 1 minus 2 1, 2 minus 1 minus 2 minus 1.
So I have written all the 4 points. So what is there any question?
X quadrant plus or minus 2, y quadrant plus or minus 1.
Okay. Oh, okay. I shifted the quadrant. Yeah, thank you so much. So it will be 2 1 and 2 minus 1. Thank you so much. It will be minus 2 and 1 and minus 2 and minus. Thank you. So in the next case, if x equal to 0, this will give you nothing but either y equal to 0 or lambda equal to 0. And if y is also 0, then it will not satisfy this subject to constraint condition because it will give you 0 square plus 2 into 0 square, which is 0, which is not equal to 6. So this is not lying on this given ellipse. The other way around is lambda is coming out to be 0, which is nothing but this will equation this f plus g lambda will stay 0 multiple, which does not value something. So we will consider only these 4 points and we will calculate the value of fxy over these points. And what is the function fxy? So points are 2 1 2 minus 1 minus 2 minus 1 and minus 2 and 1, and the function fxy is equal to this one is x square y. So this will give you 4, this will give you minus 4, this will give you again minus 4, and this will give you 4. So what is the maximum value? Maximum of our function fxy is nothing but 4, while minimum of this fxy is nothing but minus 4. Okay, I hope there is no typo and everybody is getting this answer. Okay, then let me move to the second other question. Question number 4. Find out the value of the triple integral 1 e cube 1 to e square 1 to e 1 by x y z dz dy dx. Find out the value of this triple integral. Please try it. So let us start here. 1 to e cube, 1 to e square, 1 to e. Since the function is of three variables, three independent variables, so what we can do, yes,
Sir,
please.
is 6. 6.
Yeah, your answer is correct. So here we are integrating with respect to z first. So we will treat x and y as constant and it will come out like this, 1 to e square. So we can write is 1 by xy and the integration of 1 to e 1 by z dz dy dx. So it will be 1 to e square 1 by xy. This is nothing but 1 to e dy dx. So it will give us 1 to e cube 1 to e square 1 by xy ln e minus ln 1 dy dx. Ln e is nothing but, what is the value of ln e? 1.
1.
And ln 1 is 0 dy dx. So this will be left with the double integral 1 by xy dy dx. Now since we have to do the integration with respect to y first, then we will treat this x as constant. So this will be the integration of dy. This will give us 1 to e cube 1 by x ln mod y 1 to e square dx. This will give us 1 by x ln e square minus ln 1 dx. 1 to e cube 1 by x 2 times ln e minus 0 dx, because ln x to the power n is nothing but ln x. So this will give us 1 to e cube ln e is 1, so it will be 2 by x dx. This is ln mod x 1 to e cube. Again with the same argument, you will get here 3 times of ln e minus 0, and this will give you the value 6. Okay, so someone has told the answer 6, so it is a correct answer. If everybody agrees with this explanation, then we can move to the next question. Okay, next one is find out quadratic approximation of the function e to the power x at origin. Find out the quadratic approximation of this function fxy e to the power x ln 1 plus y at the origin. This will be followed by the lecture of approximate Taylor's theorem, or in fact that error approximation. So you can follow up any one of that lecture to get the quadratic approximation of this function. So Q, I'm denoting it is a quadratic approximation, QXY. So what is QXY? QXY is nothing but if we have to do quadratic approximation of some function f at some point x naught y dot, it is equal to fx naught. The other factor is fx at x naught, that is partial derivative, into x minus x naught, fy at x naught comma y naught into y minus y naught, 1 by 2 fxx x naught comma y naught x minus x naught whole square plus 2 times fxy x naught comma y naught x minus x naught y minus y naught plus 2 not 2 fyy of x naught comma y naught into y minus y naught. I hope everybody recalls what I have written. So we need to calculate that value of f at 0, 0, value of partial derivative of f first order partial derivative as well as second order partial derivative at 0, 0. We need to calculate these values, then we have to put these values in this qxy equation. One can say equation number some star. Then we will get the quadratic approximation of our required function. So let us proceed with the calculating the first value, that is functional value at 0, 0 is nothing but e to the power 0 ln 1. So it will be 1 into 0, that is 0. Partial derivative of this function with respect to x will be nothing but we will treat this ln 1 plus y as constant, derivative of this with of e to the power x, that is e to the power x ln 1 plus y. So this will give us fx at 0, 0 again 0. Now calculate partial derivative of y, partial derivative with respect to y. So e to the power x will stay as constant, then we will differentiate ln 1 plus y, which is 1 by 1 plus y by the chain rule, partial differentiation of 1 plus y. Okay, so this will give you e to the power x divided by 1 plus y. Now we will again substitute the 0, 0 points in this, e to the power 0, 1 plus 0, which will give you 1. Okay, now the next task is to calculate the double second order partial derivative. So this will give you, what is the definition of this? This is fx of xy, partial derivative of x e to the power x ln 1 plus y. This is equal to again and fxx at 0, 0 will give you 0. Now fxy 0, 0 del by del y. Okay, I can do some more direct of fx at 0, 0. So y e to the power x ln 1 plus y at 0, 0. So this will give you e to the power x divided by 1 plus y and 0, 0. This will be nothing but 1 by 1 plus 0 equal to 1. 1 cancel 0. So the last second order partial derivative f by y is equal to, what was f by? E to the power x divided by 1 plus y. So del by del y of e to the power x 1 plus y, which is equal to e to the power x minus 1 by 1 plus y whole square into partial derivative of 1 plus y. This will come out to be 1 plus y whole square. I hope there is no disturbance from the background to you. If there is any, then please let me know. Anyone? Somebody? Are there? Anyone can confirm me? Okay, I am assuming there is no disturbance from the background. F by y at 0, 0 is nothing but 1 plus 0 whole square, which will give us minus 1. Now we got the all the first and second order partial derivative as well as the functional value at the origin. Now I just need to put these values in this equation star to get our required quadratic approximation of the following function. So qxy is first of all fx naught y naught and f0 0, that is 0. So 0 plus fx, first partial derivative at 0, 0 is again 0, 0 times x minus x naught plus fy at, that is 1, 1 time y minus y naught. Now the second order partial derivative, 1 by 2 fxx at 0, 0 is 0, 0 into x minus, here let me replace it x naught y naught with 0. So this is nothing but 0 whole square plus the fxy is 1, that is 2 times x minus 0 y minus 0 plus fy at 0, 0 is nothing but minus 1 y minus 0 whole square. So this will give us y plus 1 by 2 times of 2xy minus y square. This is the required answer. One can say this is the required quadratic approximation of the given function. I hope this is clear to everybody. Yes,
I
please.
have one doubt.
Yes, please.
The triple integral value.
Yes.
What is the triple integral value? Integral 1 to 2.
Um.
Not this problem. Another problem.
Okay.
Integral 1 to 2.
Yes.
Integral 1 to e square.
Okay.
Integral 1 to e.
Yes.
1 by x square yz.
Why is it like this?
Like dx dy dz.
Dx. Okay. Let us compute this some special question.
Here we have different answers for this problem.
Okay. Let us do it then.
How we can take? How we can decide that?
Yes, please ask.
I got different answers for this problem. What is the correct answer?
Okay. First of all, here we have to integrate with respect to x first. So this will be 1 to 2, 1 to e square, 1 to e, 1 by x square yz dx dy dz. This will be 1 to 2, 1 to e square. Since we are want to integrate with respect to x, so this will come out, and 1 to e, 1 by x square dx and dy dz. So 1 to 2, 1 to e square, 1 by yz. This will be nothing but minus 1 by x, 1 to e dy dz, 1 to 2 minus 1 by e minus minus 1 dy dz.
I know that process, but if any rule or any rule to take like that,
See,
no
I'm
rule.
okay. I'm telling you. Here we have to integrate, since here it is dx, so we have to integrate with respect to first dx. Then we have to integrate with respect to dy, or you can say y. Then we have to integrate with respect to z.
We
This
don't
is the
have any rule
no,
following that one.
no. There is no rule because here is a constant limit. If there is a limit,
Constant limit. So in that's why we can separate the x terms, y terms, and z terms, and
yes,
we can
if it is
integrating
possible,
and
then we can do
multiplying
that.
that one.
Yes,
Uh,
if it is possible, then we can do that. Otherwise,
hmm.
if we have given that some, like you can say, let me mention it here, triple integral like this. This is some g1 xy. Another one is g2 xy, f1 x, some f2 x.
Okay, I know that's our
Okay,
variable limits.
okay.
And
So
that's why we
in
can
this
take that
scenario,
order.
yeah, in this scenario we have to fix it first. Like first we
Uh,
have to integrate with
yeah,
this. Okay.
it's respectable. But in constant limits,
Yes.
why we will calculate that way?
In constant limit, why we will.
Why in that way we can calculate the value in any way we can take the limits.
So you want to
Any
ask what
any
is the
order
reason
we can
behind
take.
that?
Uh, we can take any order to
So
calculate that
I
triple
have let
integral.
I have told you in the question number 2 that I have computed that this double integral with respect to x first, then y first, then x. And also I told here that the reason is Fubini theorem. Fubini theorem for two variables is like this, like if our function is continuous on this rectangular region and we have a constant limit, then we can shift the order. In the same way, we can motivate it from this. We can extend this theorem to the three variable also. In fact, and the n variable also, that we can, if function is continuous and we can set constant limit, then the answer will be the same. Okay.
But here we can't get the same answer.
Why? See, first of all, I told you that this Fubini theorem is for two variables. For three
Hmm.
variables, it might be the different. I said that this is a motivation. So in the these three variable that you have given, what is the answer if I change the order? Let me know, please.
Hmm.
What is the answer? I don't think so. It should be changed. Is it changing?
When order changing, answer is change.
No, I don't think so. This is a constant limit.
Okay.
Shall I do it?
First you do it.
Okay.
What is the answer we are
1
getting?
to 2, 1 to e square. So this will be nothing but I am doing a little shorter way. So this will be 1 by y dy, and the left part is 1 by z dz. So this will give you 1 minus 1 by e, 1 to 2, 1 by z, ln y, in fact ln mod y, 1 to e square dz. So this will give us 2 times 1 minus c, ln mod z, 1 to 2,
Alan.
2 times ln 2 into 1 minus 1 by e. Okay, so one answer is this. Now, in which order you want me to integrate? Y or x?
I'm taking the first 1 to 2 limits for 1 by x square
So 1 to 2 limits
for 1 by x square
1 by x square dx.
dx.
Okay.
Next,
The other one is
1 to e square 1 by y
1 to e square.
dy.
See. What you have done now, let me know. Let me tell you. What you have done, you have changed the limit. Here, this limit the last one limit corresponds to z. This limit corresponds to y. This limit corresponds to x. Understood?
Why in this way taken that one? We don't have any rule for
No,
that.
no, no, no. We have that. That's what I told you in the starting also, na. Here we have given the first we are integrating with respect to x. We have given this, no? We have told you that rectangular region is like this, like our x is varying from 1 to e, our y is varying from 1 to e square, and our z is varying from 1 to 2. So they have fixed this order in this way. If you are changing x or y, then the limit also change. For example, you are saying that you want to do first of all 1 to 2 integration. So that means you are integrating it with respect to z first. Understood?
No, in in constant limits, that is not a rule.
Array. Let me tell you again.
Anyway, we can do that
No, no,
triple
no, no, no,
integral.
no, no, no. Let me tell you with the sec2 variables. Then it would be easy somewhat. Here is this Turing's theorem. Okay, this theorem is valid. For example, we have defined this rectangular region R. Okay, and we have fixed that this A will vary between A to B, and this Y will vary between C to D. So what you are doing, that you are, this is an integration A to B, C to D. Now you know this A to B varies for only dx. So that means you are integrating with respect to dy first, then dx. Now you
Okay,
are saying you are changing the this integration limit, then dx and dy will also change, na?
okay, okay, okay,
Understood?
okay, okay.
Yes. So you can
This
extend
is
this. Yeah.
extended to
Yes,
triple
exactly.
integral.
Yes, exactly. So this quadratic approximation of this function is clear to everybody?
Hello,
Yes,
hello,
yes, yes, yes. Please, बोलिए. Please speak.
hello.
Yes, Muthuji, I'm. You are audible. Please speak.
So the problem is you have to explain what is the iterated integrals and what is the difference between these two.
Iterated integrals and this. What is the second one you said?
Iterated integrals,
Yes.
multiple integrals. Are they one and the same or they different?
You are a little, your voice is a little breaking. Can you repeat your question? Iterated integrals and the what is the other term you have used?
Is there any difference between iterated integrals and multiple integrals?
See, here iterated integrals, since this is the limit, constant limits, and we are integrating with respect, treating this as a function of three variables, then here this multiple integral will become like you can separate them iteratively. You can do that integration, and that multiple integral, as I told in somewhat way that I have raised, that if we have given like this is a generalized form of the multiple integral f1x, f2x, and some a to b, some function x, y, z, or I can say dz, dy, dx. So if we have given this kind of integral, this is a general form of this multiple integral. Okay, you cannot separate in this case. But while these limits are constant, you can treat it as iterated integral. So you can separate them dz. You can explicitly first of all integrate with respect to dz or dy and dx. Then you can multiply them. But in this case, since it is our limit is depending on our function of first limit is depending on xy, and the second one is depending on x, and the third one is constant. So we cannot like shift them directly. You have to draw the region and then you have to calculate that multiple integral. But you cannot calculate in this way that iteratively, yet you can separately, you cannot calculate them. Okay. So let me move to the next question. Since the quadratic approximation is clear to everybody, so the other question is find the maximum value, correct it, maximum absolute error in the linearization of the function fxy x squared minus 3xy at point 1 comma 1 in the region R, which is defined as x minus 1 less than equal to 0.1 comma y minus 1 less than equal to 0.2. So we need to calculate absolute error in the linearization of this function. So we will try it, then we will discuss it here. So what is the linearization technique says, or that linearization error? This is from that lecture error approximation. That error approximation was nothing but m by 2 x minus x naught whole square y minus y naught this whole square, where m was nothing but maximum of all the values fxx, fyy, fxy at the point x naught comma y. So anybody is feeling any sound from the background and disturbing sound, or is it fine? Can anybody confirm me? Muthukumar ji? Hello? Just let me confirm that.
Here we can take modulus, sir, maximum of.
Mhm. Somaji, can you confirm that you are hearing any disturbance from the background, or is
Yeah,
it fine?
yeah.
Is there any disturbance?
Estimates, yeah.
Okay, let me change the place.
Noise
Then,
is not
Yes,
there
sir.
in the back.
okay, let me change the place. Please give me 2 minutes only. Hello,
Yeah.
is it fine now?
Okay.
Is it fine now?
Yeah.
Okay. Yeah, please say what you are suggesting.
We must take the modulus in maximum of.
Yeah, you're right. We need to take the modulus.
Answer is point 0.06.
0.06. Yes, it is the correct answer. So since here the double derivatives are involved, we need to first calculate these double derivatives, or you can say second order partial derivative. So fxxy is nothing but 2x minus 3y. Then again fxxxy is nothing but 2. So this will imply this double derivative at 1 comma 1 is also is equal to 2. Now f y x y, this will be minus 3x, and this double derivative of this f y x y is 0, right? So this will imply that this double derivative at 1 comma 1 is 0. Now what is the value of double derivative of fxy xy? This is nothing but minus 3. That means this will give us fxy at 1 1 is nothing but minus 3, and here the mod of role of mod will play, like we need to compute the maximum value over each of the mod. That means 2 0 and this is minus 3, so this will give us 3. Okay, so you got the value of m. Now you have to decide the bound for this x minus x naught and y minus y naught, which have somewhat given in the hinted in the given question, that this must be bounded from point 1. So what you will do, that mod Rn is nothing but less than equal to 3 by 2, and this quantity is less than point 0.1, this quantity again less than point 0.1, its square. So this will give you 3 by 2 point,
Better to write
what?
R1.
Sorry.
Instead of Rn, you can write R1.
Okay, understood your point. So we are writing here R1 because we are talking about linearization. Is it fine now? So it would be more precisable. So this will give you R1 is nothing but 0.06. Okay. So the next question is 7. If the linear approximation of fxy is equal to some this function 3y square plus 2 at some point 1 comma 1 is given by ax plus by plus c, then find the value of a plus b plus c. So we have given that a function of two variables xy minus 3y square plus 2, and we have to compute its linearization, which is given by some ax plus by plus c. Then we have to add these constants a plus b plus c. So again we are repeating the linearization technique, which is lxy f at x naught y naught plus partial derivative, first order partial derivative at x naught y naught with respect to x into x minus x naught, first order partial derivative with respect to y at x naught y naught into y minus y naught. This is the linearization of this function of two variable fxy. So let us calculate f1 comma 1. This will give you 1 minus 3 plus 2. It's nothing but 0. Now partial derivative of f with respect to x is y minus 0 plus 0, which is y. That means 1 comma 1 will be 1. Now f y 1 comma 1 will be equal to x minus 6y, which will give you, sorry, here xy. Now you will put 1 comma 1. This will give you 1 minus 6 minus 5. So put these values in the above linearization. This will give you 0 plus 1 time x minus 1 minus 5 times y minus 1, which will give you x minus 5y. This is minus 1 and this is plus 5. This will be plus 4. Okay. I hope everybody is convinced with this linearization. So let us move to the next step. We have given some ax plus by plus c type linearization form. So comparing these two, you will get the value of a as 1, b as minus 5, c as 4. So the sum of a plus b plus c is 1 minus 5 plus 4 is 0. Okay. So you have computed first this linearization of this function, and you have compared this with the given linearization equation. Then you have add these constants a plus b plus c. So let us move to the next question, which is question number A. The polar equation r cos square theta equal to 4 sin theta represents which standard curve? Which standard curve represents this polar equation? So we have done one similar question at the starting also. Can go with it.
X square equal to 4y.
Okay. So what would be the standard curve then?
X square equal to 4y.
What is the that represents?
Parabola.
Right. So we have given r cos square theta equal to this 4 sin theta. Okay. So we will multiply r on both sides so that we will get here a whole square and here 1r. So this will be r cos theta whole square 4 times r sin theta. Now we know that r cos theta is nothing but x and r sin theta is nothing but y. So this will give us x square equal to 4y, which represents the parabola. Okay. Now let me modify this one a little bit in somewhat way, like we have given r is equal to some 10 cos theta into some, you can say, second square theta. Will it be representing any? In fact, here I should write some sin theta. So this was somewhat easy, like I have manipulated a letter only. So I hope this is quite straightforward to you also. Can anybody let me know that what would be the this represent?
Let represents x square equal 10y.
Yeah, exactly. So I just what I have done, I have just take that cos square theta to the right hand side. So this is nothing but, again I'm writing in short way, r cos theta whole square 10 times r sin theta, which is equal to, again, x square equal to 10y, which is the parabola. Okay. Now let me write the next question. Question number 9. If the quadratic approximation of fxy is equal to sin x into sin y at the origin is given by ax square bxy, then what is the value of a plus b? Please tell me. We have to do its quadratic approximation, then we have to tell that what will be the value of this ax, oh sorry, this a plus b, right?
A plus b is 1. A plus b equal to 1.
If your answer is correct, that how did you get it? Can you let me know? The answer is correct. So what we have to do in this, just a second, we have to, again let me recall, qxy is nothing but x naught y naught f x at x naught y naught x minus x naught plus f y x naught y naught y minus y naught 1 by 2 f x x x naught comma y naught x minus x naught whole square 2 times f x y x naught y naught x minus x naught y minus y naught plus f y y x naught y naught into y minus y naught whole square. So we need to calculate these partial derivatives and this f at 1 1. Our point was, wait, origin. Okay, 0 0. So what is the value of f at 0 0? This is sine 0 into sine 0, which is nothing but 0. Now f x x y is nothing but cos x sine y. Then the value of this at 0 0 is again 1 into 0, which is 0. Now fy xy is equal to sin x cos y, which is equal to fy at 0 0, that is 0 into 1, that is again 0. fxx xy is equal to minus sin x sin y. Fx at 0, 0 is again 0. Now fxy at xy, which is equal to cos x cos y, which will give us fxy at 0, 0, which is 1. Now fyy xy is equal to minus sin x into sin y. Is it correct? This will give us fyy at 0, 0 is 0. So we have got all the values 0 except this factor xy. So we will put these value in this quadratic expression and we will get qxy is nothing but 1 by 2. The other factors are 0, so I am not writing that. X minus 0, y minus 0. So this will give us xy. So, and we have given the form ax square plus bxy. So we have given qxy is equal to ax square plus bxy. So from here a is equal to 0 and b is equal to 1. Therefore, the sum of these quantity is nothing but 1. Okay. Everybody is okay with this?
Sir, how can we know that we have to use a Taylor series for two variable function?
See, we have given that quadratic approximation. So
Yes, sir.
in that lecture of
Okay.
error approximation, if you remember that, we have to approximate this function up to some quadratic polynomial. Okay. So up to quadratic
Yes.
polynomial, it means that we have to use the Taylor series up to the second order. Okay.
Up
In
to
rough
second
language,
order.
I would
Okay,
say.
sir.
Okay.
So we have to leave the third order derivatives and third order term.
That in the remainder term. Okay.
Okay, sir.
In the
Okay, sir.
same way,
Fine.
if it has given linear, then we have to do that up to first order partial derivative.
Only
Okay.
first order terms.
Yes.
Okay, sir. Thank you.
And anybody can tell me what is the speciality? Like we have given that origin. So that Taylor series will become some special name. What's the special name of that series? Anyone?
Maclaurin series.
Maclaurin series. Right. So if we are calculating this Taylor series at some origin, or we are doing that approximation that is somewhat a Maclaurin series approximation, or we are applying Maclaurin theorem. Okay. So the next question is, if a point P A comma B comma C on the plane x plus 2y minus 3z equal to 7 is the closest to 0, 0, then find the value of a minus b plus c. So we have given a plane and we have subject to constant, like this is a plane, and we have to calculate this distance, and we know that this point has minimum distance from this 0, 0. So I have this is the origin, so it will be 0, 0, 0. Okay, right. कर दो मैंने म्यूट कर बहुत शोर हो रहा है बहुत ज्यादा शोर हो रहा है आज की लेक्चर रिकॉर्डिंग बेकार होगी मोबाइल लेके जाना है मम्मी का ले जाओ गेट जरूर तुम्हारा. Anybody got any answer? So any tentative approach that what we have to follow, which method or any approach?
So since the point lies on the plane, the point must and should satisfy the plane equation.
Okay.
That is a plus 2b minus 3c equal to 7.
Okay.
It is closest. Closest means we can calculate a distance.
Hmm.
The distance we have to find out.
So the distance
Uh,
is nothing but
Square root of x square plus y square plus z square, because it is from origin.
okay. So this is nothing but we have to that minimize, since it is closest, then we have to
Yes.
minimize the function x square plus y square plus z square. It is does not matter like we have taking under root or not. We are just want to minimize. Okay. And subject to constraint is x plus 2y minus 3z minus 7 equal to 0. Now try it. We know what is fxy, we know what is gxyz. Now we have to apply the Lagrange multiplier to calculate this a, b, and c. Right. So we have f x y z x square y square plus z square. Okay. And g x y z is equal to x plus 2y minus 3z minus 7. Now by Lagrange multiplier, del f is equal to lambda times del g. What is del f? Del by del x f at I cap, del f by del y j cap, del f by del z k cap. So this will give us, since it is x square plus y square plus z square, sorry, 2y j cap, 2z k cap. While del g is a linear function, so this will simply give I cap plus 2j cap minus 3k cap. Okay, now equate them with multiplying lambda. So it will be 2x I cap, 2y j cap, 2z k cap. I'm sorry, that lambda I cap plus 2 lambda j cap minus 3 lambda k cap. Okay, so this will give us 2x equal to lambda, 2y equal to 2 lambda, 2z equal to minus 3 lambda. Okay, so this will give you x is equal to lambda by 2, y is equal to lambda, z is equal to minus 3 lambda by 2. Now what would be the next step? Anybody? What would be the next step?
X, Y, Z in the given plane equation.
Nice. X, Y, Z, we have given that will set lie on the
We can
plane.
calculate lambda.
Yeah, we can calculate lambda. So we have given x plus 2y minus 3z equal to 7, right? So we will put the value, substitute it, 2 lambda minus minus will get plus, 9 lambda by 2 is equal to 7. So lambda will common, 1 by 2 plus 2 plus 9 by 2, 9 plus 1 10, 10 divided by 2 5, 5 plus 2 7, and lambda will be equal to 1. Okay, and since lambda equal to 1, now by this star you can say that x will be 1 by 2, y will be 1, and z will be minus 3 by 2. Now you know the point, and we have given p was a, b, comma c, or you can calculate the value, its functional value, which is not asked, but I'm just letting you know. This will be the minimum value. What we have asked is, we have given that a, b, c are our points, and we have to calculate a minus b plus c. So here a will be half, b will be 1, and c will be minus 3 by 2. So we have asked a minus b plus c. This will come out to be 1 by 2 minus 1 minus 3 by 2. What will be the value of this? 3 minus 1 minus minus 2, right? Any doubt?
Sir, we can calculate by using Lagrange's method of multipliers. The new function we will define as f equal to small f plus lambda phi. So phi
Yes,
is constrained.
yes,
In
you
that
can.
method also we can calculate, sir. Stationary point we will get.
Yes, exactly.
Using
And
that point, we can
let
calculate
me
required
let
value.
me express that method explicitly to you. Here, what we are doing,
So
we
that is
are,
we are defining new function.
yeah, exactly.
Yes.
We have given some maxima minima of some f x y z, and subject to constraint we have given some
அப்படி
gx.
வந்து அதான்
Constrained as plane equation.
சரி இப்போ
Yes.
கூட்டிக்கிட்டு போ. அது கதவை சாத்திட்டு இல்ல மெயின் டோர்.
Muthuji, can you mute yourself?
சரி சரி.
So the
அந்த
one way,
டேபிள் இடியப்பம் இருந்துச்சு இல்ல,
Muthuji,
அந்த டேபிள் இருக்கு, அது வந்து நல்லா இல்ல, அதை தூக்கி போட்டு வெளியில. ஆமா, ஏதாவது அந்த பக்கம் நாய் சாப்பிடுற மாதிரி எங்கேயாவது பார்த்து போட்டு.
Muthuji, can you mute yourself?
அது டேபிள் மேலே இருக்கு. சரி.
Okay. Muthukumarji, am I audible? Okay. So what we can do here, one way is that we are just this multiplier, we are equating this Lagrange multiplier. The another way is told by someone is that we can define a new function of x, y, z and lambda as f x, y, z plus lambda times some g x, y, z. Then we can calculate del h by del x, del h by del y, del h by del z, and del h by del lambda, and we will put all of them is equal to 0, and this is nothing but, this last one is nothing but g x y z is equal to 0. Okay, so from here we can get the stationary point, then we can follow that Lagrange multiplier approach. There is nothing different with that approach we are following. I hope it is clear to everybody. Anybody has any doubt? So shall I move forward? Mr. Abdul, you have asked this thing, so is it clear now? Yes, please speak. Just a second. Just a second. Now try if you can able to speak.
Yes, sir. Thank you, sir.
Yeah, sorry
We
about
can
that
use
time I have to use that time I have to mute all of them because someone is not able to put his mic on mute.
Show me above answer one time.
Yes,
Previous
yes, please.
answer. What is the point here? What is the value of lambda?
Value of lambda is 1.
Here we have minus 9 lambda by 2. No? Plane equation.
Uh,
Even
mi
plane equation is
we have
minus
given
3 lambda.
minus 3 lambda by 2 and here is minus 3z, so it will be plus.
Okay.
Okay?
Okay.
Okay. Yeah, Abdul. Yeah, you can speak now.
no, sir. Nothing, sir.
Okay.
It's all okay, sir.
Okay.
So that is we will get the stationary point directly by using this method also.
Yes.
Okay, sir. No problem, sir.
So before going to the next question, I would like to discuss some two questions from the tutorial, last week tutorial and the first week tutorial that we have discussed in somewhat way. Now let me explain it explicitly. So I have mentioned in the PDF also that here a note we have mentioned that someone asked, we what if we take here rather than this 2 4 6, what if we take here 1 2 3, whether the answer will change or answer will not change. And the question arises over the well-definedness of the problem. So earlier we all of us have made missed one thing that in the given question we have given here 6. They have already told us that here should be 6. After that we will calculate P, Q and R. Then we will calculate this value P plus Q minus R. Okay. So if we will do that 1 2 3, then here it will come 3. So you cannot compare this with the above equation. So the above defined problem is well defined in the way we have given here 6. For example, if we have given some 1 plus pt and some y 1 minus qt plus z is equal to some suppose 1 minus rt. Then we can say that we can change PQR and here it will come minus 1. From here it will come 1 plus 2 minus 3, which will be some value 0. Okay. Then answer will change. Then we can arise here that the question is not well defined. But as we have given here the 6, that means this question is already well defined because it will not allow us to change here this factor 246 by 123. So we cannot do this particularly in this question so that the answer will be unique. Earlier in the last class we have discussed and we have concluded that answer can be more than one answer, but here the answer will be unique. The reason is the well-definedness of the problem. Okay. Anybody has any doubt in this? Now, the student who has raised this point in the last class has any doubt? Okay. Now the next discussing point is from the tutorial 1. In the tutorial 1, someone has asked that how we are getting that in how we are solving that inverse trigonometric problem. Let me move to that first. Here I have updated the PDF in that folder also, so you can go there and check it also. Now let me tell here that we need to prove here that limit e to the power x tan inverse phi divided by y is 1. We want to prove this. So let me prove it explicitly. Limit tan inverse y, this is nothing but 1. So we need to prove this. So I have let you know my approach that we know that sin x is nothing but less than x is nothing but tan x. If you will draw their graphs also, you will get to know that this is sin x, and I'm talking about x greater than equal to 0. And I will also let you know why I am saying here x is greater than equal to 0, because inequality will reverse. And what will be the x equal to y? Here, this is a rough diagram. Now this is some 10y. Okay, so for x greater than 0, you can easily see that tan x is greater than x is greater than sin x. So from here we will get sin tan inverse x less than equal to tan inverse x less than equal to x for x greater than equal to 0. Someone has asked how we are getting this sin tan inverse x equal to some x by under root 1 plus x square. Earlier there was a typo that I have mentioned that this is x by 1 plus x square. So this will be x by under root 1 plus x square. So how I am getting that? Let me tell you. So here it is tan inverse x. Suppose this is some theta. Okay. Now tan theta is nothing but x by 1. Now by Pythagoras you can see that this is perpendicular length, this is base length. So what will be this? 1 plus x square. So since here it is sine, so we have to compute some sine inverse so that sine and sine will cancel out. So this will give you sine theta perpendicular divided by hypotenuse length. Okay, so this will give you theta is equal to sine inverse x by what is the value? Theta is tan inverse x. Now theta is become in the terms of sines. So you can put this in the inequality and you will get x by 1 plus x square is less than equal to tan inverse x less than equal to x. Now from here you can see here x is greater than 0, 1 plus x square less than equal to tan inverse x divided by x less than equal to 1. Now from here you can see that limit x tending to 0 positive. Since I am only talking about x is greater than equal to 0, so I can only calculate the limit from the right hand side. So this will be 1, which is same as limit x tending to 0 positive tan inverse x divided by x. Sorry, here I should first write 1 because here the function is 1 or here the function is. So this will imply by squeeze theorem, by squeeze theorem, we can say that limit x tending to 0 positive tan inverse x by x is 1. Now we know about the right hand limit. What will be the left hand limit of this tan inverse x by x, and what can be the possible argument for this? Can anybody let me know? What can be the possible argument to prove limit x tending to 0 minus tan inverse x by x is 1. Because only in that case we can guarantee that limiting value of this tan inverse x by x while x tending to 0 is 1. So we need to prove the left hand side also, left hand limit also. So how we will calculate, or you can show this tan inverse x by x is also 1. Anybody think about it? Ah, any idea? See,
Sir, same as above, sir. Same as above.
but
Last,
inequality will change. Observe here from graph. What will be the inequality? Tell me. Which will be the greater side? See here these three graphs. Then you will get to know. Tell me what will be the possible inequality from here. Abdul? Same. Here the values are negative. So whichever at the downside will be the lesser value. So tan x is at down, so it will be the less than x, then sin x, and for x less than equal to 0. So this is our other way around inequality. I can say it is cut. Just a second, please. It is disturbing somewhat. Let me write it again. I'm sorry for the disturbance. So it will be 10x less than equal to x less than equal to sin x for x less than equal to 0. Okay. Again, you will make here x. So it will be x tan inverse x sin tan inverse x, where x less than equal to 0. So this will be nothing but what was sin tan inverse x? That was x by under root 1 plus x square for x less than equal to 0. Okay. So this is 1 less than tan inverse x divided by x divided by, so this will give us limit x tending to 0 minus of 1 is 1, which is same as limit x tending to 0 minus 1 by under root 1 plus x square, which will give us by squeeze theorem tan inverse x divided by x is nothing but 1. So from this hash equation and this star equation, this will tell us about the right hand limit, while this tell us about left hand limit. So from this right hand and left hand limit is same, so we can say that this limit exists and will equal to 1.
sir, is it possible to prove this inequality by using Lagrange's method, sir? Lagrange's mean value theorem.
Lagrange mean
While
limit.
taking f of x as a tan inverse x and the
Hmm.
functional value at 0,
Hmm.
using the limit value, limit extends to 0, f of x minus f of 0 by x minus 0, by
Hmm.
taking left hand limit, right hand limit,
But
and
from
we were
that, what do you want to prove? That this inequality or something else?
value, sir, limit value, limit extends to 0, tan inverse x by x value 1, this value, sir.
So you want to say like this, tan inverse 0.
Yes, sir. Yes, sir.
So what will be this value?
1, sir, 1. Uh,
Okay, you are doing nothing but, let me know, let me tell you, you are doing here kind of differentiating or
yes, sir.
L'Hopital rule, you can say.
F dash of x, F dash of x. Yes, sir.
Actually, actually, that your argument is correct, but
Uh,
since I have others let them know in this first tutorial with the help of this inequality approach, and one student has asked me how I am getting this sine tan inverse y is equal to y by under root 1 plus y square. So
yes, sir.
that
You
that
are
time,
taking a long process.
yeah, I know, but this is the real analysis process. If I would suggest
Yes,
you.
sir. Yes,
So
sir.
the squeeze theorem, if you get, you are giving some subjective paper, in that scenario, you can apply the Lagrange multiplier. I'm not saying Lagrange mean value
Okay.
theorem you cannot apply, but this will be a better way as a real analysis expert that you are applying squeeze theorem. You are seeing
Sure.
some things in that form. So, my main perspective was to explain you that how this sine tan inverse y is equal to y by under root 1 plus y. Okay. And
Okay.
these notes I have also been updated in the same way. In the last tutorial, there has been a discussion about this well-definedness of the problem, well-definedness of this problem. That also I have updated in that PDF, and also with the help of this note I have updated. Okay, so I hope this will not create any confusion further. And now let me give you one last glimpse of one last question, that is drawing a polar curve. That also in the lecture, if you have noticed, that sir has emphasized that drawing a polar curve will be a necessary task in our further study. So let me give you one question. Trace the polar curve R is equal to a 1 plus cos theta, where a is positive. Right. This has been a separate lecture in this week 4 lecture series, that is polar curve. Right. How can we do it?
Sir, it is cardioid, sir.
Yeah,
We
it
can
is.
trace it as using
Uh,
a few points, sir. That is
okay.
about symmetry,
Yeah,
origin,
exactly.
passing
Yeah,
through pole.
exactly. That you are telling. I was asking exactly that how will you prove that this is symmetry? How will you judge that this lie in this quadrant, or which quadrant it will lie?
Sir, we have a procedure, sir, that symmetry means while
Yes,
theta is replaced with minus theta, if the curve remains unaltered, then the curve is symmetrical about initial line, sir.
exactly. So first of all, to check the symmetry about the initial line,
Yes, sir.
check the symmetry about theta equal to 0, or you can say initial line. What we will do, we will replace
Theta by
theta by
minus theta.
minus theta. So it will give us r equal to a times 1 plus cos minus theta, which will remain unaffected, this curve equation, which is 1 plus cos theta. Now check about some theta equal to pi by 2. So to check theta equal to pi by 2, what we will replace? We will replace
Pi minus theta, sir.
pi minus theta. Good. So this will give us 8 1 plus cos pi minus theta. What it will give? 1 minus, right?
Yes, sir.
So this will not same as a into 1 plus cos theta. So it is not symmetric about theta equal to pi by
Whole
2.
line.
Now, what about pole? Pole means
Pi plus theta, sir.
for pole.
Pole and origin, sir. Origin, that means radius
Replace
having 0.
r by minus r for pole. Okay.
Yes.
So it will give us minus r equal to a into 1 plus cos theta. So which will change our equation again. So that means our polar curve is symmetric about theta equal to 0, or you can say initial line. Okay. Or you can also check about theta equal to pi. How we can check about theta equal to pi? Tell me. How you will check?
Sir, about theta equal to pi, just we have to replace in the given curve, sir.
What you have to
We will
replace?
get a value, R value as 2a.
Hmm.
So hence the curve passing through the point 2a pi.
2a. So
Sir,
I hope this will imply that our given curve is symmetric about initial line. Okay.
initial.
What is our next task? We have done about the symmetry. What can we do next task? Tell me. What can be the
Intersection point, sir.
intersection point of which?
About initial line, pole line, and pi line,
Okay.
3 pi by 2
So
line.
to check the intersection point, or you can say, if I would emphasize in the way that we need to check where this touches this pole. Pole means r equal to 0. That means a into 1 plus cos theta will be equal to 0. That means cos theta is equal to minus 1, because a is strictly greater than 0. Cos theta minus 1 means theta equal to
Pi,
pi. Okay,
real number.
real number. Is there any other possibility between 0 to 2 pi?
In between 0 to pi, pi by 2, sir. There will.
No, no, no.
Sir.
Cos theta is minus 1.
Okay. Sir,
Okay,
theta maybe 3 pi.
3 pi. And what is 3 pi? Again, pi, na? I am asking for between 0 to 2 pi. Understood my point? So
Yes,
let
sir.
us draw some values here. When theta is 0, our r is a into 1 plus cos theta. What it will give? When theta is 0, 2a?
2a.
Good. When our theta is pi by 2, a. Pi, this is giving 0.
0.
3 pi by 2, a. So is there any need to discuss about 2 pi? Tell me. If yes, then why? If no, then why?
Cos 2 pi is 1, sir. 2a. Again, we will have same value.
Same value. 2 pi is nothing
Period.
but equivalent to 0. Okay.
Yes.
Now we know that our curve is symmetric about the initial line, that is theta equal to 0, here theta equal to pi by 2, here theta equal to pi, theta equal to 3 pi by 2, and this is nothing but again 2 pi.
2 pi.
And what we know, when our curve is 0, so it is 2a, some positive value. Okay. When it is pi by 2, then it is reaching some like this, pi, sorry, a. Okay. What if it is pi? When it is pi, it will go to 0. And since our curve is symmetric about this theta equal to 0, then this will again come like this. And this is a rough diagram, so it might be not look like that. So this is a famous name, cardioid. Okay, I just want to give you a glimpse that how to draw polar curves by discussing this graph. I hope it is clear to everybody.
Yes, sir. Here pipeline is also tangent line, sir, at the pole because the shape is like that, sir.
Yeah, exactly. This is a tangent line. You are talking about this?
Pipe. Yes, sir.
Are you sure this is a tangent line?
Yes, sir. Tangent
With
line.
only theta equal to pi, right?
Pipe. Yes, sir.
Nothing else. So
Yes, sir.
if anybody has any doubt, then please ask. Otherwise, let's end today's session.